Okay. Okay, so now let's see this question. This question came in GATE 2016. The question is PQRS represent the following propositions, and 4 propositions are given. The integer x greater than or equal to 2 which satisfies this relation is what? Okay, so so basically overall this thing is going to be something like this. See, not of a, see, if you see, this thing is entire thing is given by odd. So firstly De Morgan's rule we will apply, and then this thing will become not of p implication q. So this thing is not of only this thing, or and will become or. Okay, and then it will be not of the right part. Not of the right part is not r or not s. Okay, now firstly let's try to understand that what is this part. And here also in the meantime we will write p implication q as like not p or q, or and we'll write, see, again De Morgan's rule, so it will be r and s. Okay, now this thing can be written as, so again if we apply De Morgan's rule here also, it will be p and not q, or r and s. Okay, so once this is done, then we will apply a trick here. So what is going to happen is that, see, first of all we are talking about x greater than or equal to 2. So we are talking about prime and composite. Okay, and some people are confused whether one is prime or not, so they have basically removed all the confusion. X is greater than or equal to 2. Essentially one is neither prime nor composite, some people say, and some people say it is composite. So anyways, leave it. The point is that we are going to deal with only numbers, these numbers. And here if we are talking about prime and composite, then if x is greater than or equal to 2, we are talking about only one thing, that if something is prime then it is not composite, or something is composite then it is not prime. So basically my point is that q and s, there is a relation, and that is the important thing I wanted to point out, that not q is equal to s. If something is not composite then it is prime, and similarly not s is equal to q, right? So this relation I can use it here because it will solve the problem. See, if I do something like p and instead of not q I write s, then now I have something like this. Okay, I can simplify it further, but what will happen is that here only we can get rid of one term. See why? When we are talking about r and s, so r and s, so x is a perfect square and also x is a prime number, and x is greater than or equal to 2. If anything, x is greater than or equal to 2, if it is a prime, it cannot be a perfect square, right? Because perfect square literally means like it is 4, 9, 16, something like that. That there is definitely a factor uh, between that number and 1, and that's why it is definitely not prime. So all perfect squares like this greater than or equal to 2 will be composite, right? So it will not be prime. So when somebody is saying that okay, it is a perfect square as well as it is prime and x is greater than or equal to 2, they are essentially saying wrong thing. So basically this thing cannot happen. So this thing is false, and anything or false, it means that thing boils down to the left part. So this thing is basically p and s. So the entire expression which they have given, that boils down to p and s. What is p? P is this set, x belongs to something, and s is, x is a prime number. So finally we just have to see that okay, in this set x is a prime number, and so it is add that x should be a prime number and that should belong to this set, which means we have to simply find the prime number which is in this set, and turns out there is only one number, 11, which is the case. So 8, 9, 10, 12, they are not primes. The only prime in this set is 11. So the x which satisfies all these things is that x is basically what, 11. So the answer is 1, 1, 11.